Okay. Now, I will go ahead and tell you we had an exit ticket today on a problem out of Review 2. On Thursday, I'm going to choose a different problem out of Review 2, and it's going to be a quiz grade. Okay, so it's probably, going to be a good idea. Start looking at Review 2 if you haven't already done so. We'll go ahead and start it today. So the further we get with Review 2, that'll kind of narrow it down and help you figure out, what problem is going to be the quiz. All right, so what we talked about yesterday, because it was your day to go ahead and work and get as far as you could, I went ahead and just finished all the problems that we had yet to complete. Okay. Slow down. Right, come on in, guys. And we'll just go ahead and talk through them. If anybody has any questions, great. If not, that's also super fine. We will just continue and see how far we get. Okay, so this is what I ultimately ended up with for the truth table we were working on. I believe we started Monday. Or no, was it last week? Yeah, it was last week, right? Yeah, okay. So I got all truths in the very last column. What do we call that if it's all truths? That was a tautology. If it was all false, contradiction. Okay. Did everybody agree with what I got? Did we have any questions about the remaining parts of the truth table? Okay. Then the next problem. This one was kind of going back to transformations. This was more algebraic. Given this diagram of the parent x squared, and then the following diagrams, go ahead and change x squared appropriately. So diagram 2 is just a vertical shift. So x squared plus 3. B, diagram 3, that is a horizontal shift. Now here's the thing. Transforming a function horizontally is always trickier than the vertical. If you're wanting to simply move left or right, you have to take the what? You guys remember? So let's see, I want to move right, but you'll notice, what did I do in the function? I put minus. So what would have happened if I put x plus 2 squared? There you go. You have to take the opposite of the direction you actually want. And you also have to be careful about the horizontal dilations. Let's say I were to give you this. Okay. Now I know this is a horizontal dilation because, see, I'm directly affecting x before I apply the function, the square, before it becomes a y value. So would this be a stretch or a shrink horizontally? This would be a shrink. By what factor? Okay. Hello. By what factor? By 1/2. Okay, when you're multiplying x and you're wanting to change, you're wanting to dilate it, I should say, horizontally, you have to take the reciprocal of what you have. The reciprocal is actually the true scale factor. So if I were to go ahead and plug in, say, 1/2 x and then squared, that would stretch it horizontally by a factor of 2. Okay, do you guys remember that? Kind of, sort of? Okay. That's good, good. And then you'll notice C, diagram 4 was just a combination of the two. It was shifted both right and then up 3. So x minus 2 squared plus 3. Anybody have any questions on those? Okay. Let's see what else we have here. Then we had a probability problem, reaching into some jars and pulling out some black balls or some white balls. Okay, so A, the probability should have been 7/15. Okay, sorry. Hold on, I think I may have skipped an answer here. That's review 2. Hang on a second. Oh, okay, A was just to go ahead and draw the diagram. Okay, so B, there we go. That was this time. Okay. Oh, and Hillary, we just did an exit ticket. Did you want to go ahead and come in the morning, or do you want to go ahead and take care of it now? 12 minutes. Just do it now. Would anybody be willing to go out there again, or because I let you guys work together? Completely voluntary. You okay with that? Okay. It is chi-squared, so you'll want to bring those appropriate notes. Where's my... All right, there you go, ma'am. All right, I'll give you about a minute. Started. Okay, so the probability that a white ball is drawn was 7/15. The probability that both balls are white, 3/20. Okay. Any questions on this one? How many people attempted it and got it correct? Okay, so that's a good number. Anything you wanted to talk about on this? If I'm following along one branch, one particular branch, like let's say, for example, I don't know, maybe this guy right here. What do we call that? Is a branch the intersection or a union? Okay, that's the intersection. So you multiply the consecutive probabilities as you go along that branch. Now, if more than one branch has the outcome that you're looking for, you combine those, you just add them, that's a union. Okay. So we're good on this one? Okay. And then we have the cumulative frequency table. Okay, the following table shows the times to the nearest minute taken by 100 students to complete a mathematics test. Okay, and there's my intervals. Construct a cumulative frequency table. Now it says use the upper class boundaries 15.5, 20.5. So it tells you how it wants you to go ahead and create this. So this is what I came up with. Now since there wasn't an interval less than 11, I just went ahead and created one to kind of start it out. I don't think it's necessary, but I went ahead and did that. Okay. So then 10.5 to 15.5, 15.5 to 20.5. So I included the upper boundary, but I didn't include the lower one. So whatever the value was, it ended up in the appropriate class interval. Now, how do we get cumulative frequency? Yeah, you just add up the frequency as you go along. Remember, frequency just refers to the number of elements in that particular class. Here we're talking about students who fell in that particular range. So we started with the 0, then we had 7, plus 13 is 20, plus 25 is 45, all the way down to 100. And then it even gives you specific instructions on how to create your cumulative frequency graph. Now remember, the ordered pairs are going to be created using the upper interval value. That's going to be the x value, and the cumulative frequency is your y value. That's how the ordered pairs are created. And typically with a graph like this, you'll see something that looks kind of like a lazy S. Okay. Do you guys remember what we called it if we actually use straight segments instead of just drawing a curve? This goes way back to vocabulary. You remember how to pronounce that? Ogive. We called that an ogive graph. Okay. All right. But if you were to take the values that we had here and graph them as discussed, okay. So, you know, the points in red are the values that I got from the previous table. Okay. And then the question says, okay, C1 or CI, use your graph to estimate the number of students that completed the task in less than 17.5 minutes. Okay, so what I did based on my graph here, I located what I believe to be 17.5, and then I just went straight up and found the corresponding value to that. So I got about 10. Okay. Now, is this the type of question where it's probably not going to be exact? They'll probably give a little leeway? Yeah. Now, again, how much leeway? We probably have to check the mark scheme on that, or maybe it even comes up to the particular grader. Okay. And then the next question, the time it will take for 3/4 of the students to complete the task. Okay. Well, I went ahead and chose 75 because 3/4 of the 100 students is 75. And then I just went straight across, hit the graph, came down. I got about 31 minutes. Okay. How close were you guys on those? You got 31 as well? What'd you get on the other one? 10? 11? 10? Good. You got 11? Okay. Good. Any questions on that? Hey. No. I just did that in case someone had a question, okay, so that you could see how I was able to get these values over here. I don't think it's necessary. As long as you have the values they're looking for, it should be fine. Okay. All right, good. And then I believe after that, we had 6 and 7, and we'd already done those, I believe, as part of another exit ticket. Okay, so our first review is done. Yay! Now, review 2. There's only 5 more to go. Okay, now remember, one of these other questions is going to end up being a what? A quiz. Well, you know for sure it's not 4. That was your exit ticket. Okay, so I believe there are 9 questions here, so that leaves 8. Okay, why don't we just go ahead and start with number 1, and let's see how far we can get. Okay, number 1. At Jumbo's Burger Bar, Jumbo burgers cost is that pounds? Looks like pounds to me. Pounds each, and regular Cokes cost C pounds each. Okay. 2 Jumbo burgers and 3 regular Cokes cost $5.95 pounds, however you say that. Okay, write an equation to show this. What should my equation be? Okay, so the burgers cost J pounds, and how many did we buy? 2. So I would say 2J plus, okay, 3C. Bless you. Okay. I mean, you could. But, you know, when you're writing these equations, typically if you're going to go ahead and write a system, your equations are going to be specific to something. It could represent the total number of items that you're looking at, while typically another equation could represent the amount of money that you're spending. So, I mean, you could. I don't think they would ding you for that. Okay. And then it is equal to 5.95. There we go. Now, if 1 Jumbo burger costs 2.15 pounds, what's the cost in pence of 1 regular Coke? See, this is another example. I am not 100% on, European currency. I got no clue what a pence is or how it relates to American currency, but we can still solve the problem, right? Yeah. Okay. Yeah. So what do I do? There you go. 1 Jumbo burger costs $2.50. I said $2.15. Sorry, pounds. So 2 times 2.15 plus 3C, 5.95. Okay. So if I double 2.15, 4.30 plus 3C equals 5.95. 3C. This problem is pretty 3C. Very easy, 3C. Not one of my best. Yeah, kind of. Okay. Well, it's not snooker, but you know. Okay. All right. So now, what would 3C equal? Okay. 1.65, and then we're going to go ahead and divide through. What do I get? $0.55. 0.55 pence. There we go. Question. Easy? Okay. That was pretty straightforward. I mean, those are the questions I would like to see, but some of them, they're going to vary in difficulty. You're going to have some easy ones, some medium ones, and then you're going to have some hard ones. Okay. In fact, in order to help you out with that, did anybody happen to go look at the website last night after my suggestion? So many hands. Okay, I will show you before I go ahead and leave today. All right. So we should be able to probably get away with one more problem, if I'm going to go ahead and show you that. Number 2, the table below shows the relative frequencies of the ages of the students at Ingham High School. What's relative frequency? Is that like the percentage? That's the percentage, yes. Okay, so I know however many 13-year-olds in the school, it represents 11% of the population and so on. So if a student is randomly selected from this school, find the probability that the student is 15 years old. Yeah, so it'd just be 0.23 or 23%. There you go. Find the probability that the student is 16 years of age or older. There you go. So I'm going to want to include 16 and everything above it. So yeah, 0.36 or 36%. Okay. You know, especially when it comes to the paper exams, I'm always of the opinion that more is always better. Err on the side of caution just to be on the safe side. Okay. But, that's just me, just in case I happen to make a mistake, which I know never happens, right? Is this thing on? Okay. But, yeah, just in case I make a mistake, I've got that work to fall back on. At least maybe I can get some points on it. Okay, final question for number 2. There are 1,200 students at Ingham High School. Calculate the number of 15-year-old students. Yeah, so all I want to do is take the percentage, the 0.23, times, what do you got, 1,200? And you said it was what? 276. 276 students. Boom. Okay. Questions? All right, so that's already 2 problems down, 3 total out of the second review. So how many possibilities are there for the quiz? 6. Okay. So how many people are going to go home tonight and just work on second review? So many hands going up. At least you're honest. Okay. Well, let me go ahead and show you this very quickly. Okay. Let's see here. If we go to the class website. Okay. Now, I think this is going to be really useful to you. Normally, there's another website that I use, but it looks like they've changed it drastically, and now they're even charging people to use it. So I went and found something different. If you go to our website, okay, it's under the most current week we're in, 22nd to the 26th. But right here, IB Math Studies, SL, and HL, if you click on it, it'll take you to this website right here, and OSC has a really good reputation for the type of materials they use, okay, answers, methods. So we're going to want what? Okay, mathematical studies, okay, and you'll notice here's all of our topics. So if you're looking for something in particular, like let's say you want more problems about, some type of statistics, maybe chi-squared or something like that. Here's normal distribution, chi-squared. You go ahead and click on these. It even tells you what kind of problem it is. Easy, medium, hard, okay? But what's really cool about this, let's choose one. See, here's the entire problem. Now, the only thing is they use a different version calculator, but that's not going to be a big deal. If you forget the keystrokes, just let me know. What's really nice about this, you can try to work the problem on your own. If you get stuck or you want to check yourself.
In this example, we have a long paper 2 problem. And we are given that there are 100 IB students in a school. And they...
Okay, so it walks you through the entire problem. And you've got a lot of problems here that you can choose from. All these different categories. Okay. So if you happen to finish up the review, or maybe you get stuck, you want to look at a problem very similar to it, the link is right there on the website. Okay, so that is available for you. I would definitely take advantage of that. That can help you out a lot. Now, just so we're all on the same page, let's go to YouTube. Snooker. Let's see what snooker is. Ronnie O'Sullivan knocked out by amateur James Cahill. Ooh, it's...
I read about that. Celebrate the iconic Crucible Theater. Glorious arena of champions.
Okay, so that's a snooker table. No, it looks like a pool table to me.
It's very similar.
It looks a lot wider, though. Yeah. Okay. John, would you poke your head out and tell... Well, that too. But would you poke your head out and tell Hillary to come on in? So that is snooker. To me, it looks like a huge table. But I couldn't tell you what the differences are. I have no idea. I mean, it looks super intense. Okay. It does. Ha! Intense. I like that. Okay, but there you go. All right.